the limit as x goes to negative infinity of the square root of 9x squared minus x over x squared plus 1. This time, x is approaching a very large arbitrary negative number. This is not a rational function, but we can still employ the tricks when finding the limit as x goes to infinity or negative infinity. We divide it by the highest degree in the denominator, which is x squared, to every single term in the limit expression. To obtain the limits at x goes to negative infinity, the denominator is 1 plus 1 over x squared. In the numerator, x squared inside the radical is the square root of x to the fourth. And so we will take each of the terms in the radical and divide it by x to the fourth instead of x squared. Simplifying this, we have the limit at x goes to negative infinity of 9 over x squared minus 1 over x cubed, 1 plus 1 over x squared. At x goes to negative infinity, 1 over x squared goes to 0, negative 1 over x cubed goes to 0, and 9 over x squared goes to 0. In the numerator, we end up with the square root of 0, and in the denominator, we end up with 1, so the answer is 0. The limit as x goes to infinity of the square root of the quantity x squared plus 1, at x goes to infinity, x squared also goes to infinity, and so the argument of the square roots is a very large number, and the square root of a very large number is also a very large number. But to show your work, we will try to factor out x squared to see what happens. If we factor out x squared, then we would end up with 1 plus 1 over x squared. And as x goes to infinity, x is positive, and so we can separate the radical by writing the square root of x squared times the square root of 1 plus 1 over x squared. This is the limit at x goes to infinity of x times the square root of 1 plus 1 over x squared. At x goes to infinity, 1 over x squared goes to 0, and so the square root of 1 plus 0 is the square root of 1. We end up with the limit at x goes to infinity of x, but x is the identity, and so x goes to infinity, x goes to infinity. The limit as x goes to infinity of the square root of x squared plus x minus the square root of x squared minus x. If we try to evaluate the limit at infinity, we would end up with infinity minus infinity, which doesn't tell us anything. And so we will attempt to multiply the conjugate, the square root of x squared plus x, plus the square root of x squared minus x, and we multiply the denominator with the same expression. This is known as the well-chosen one. In the numerator, it is now the product of the conjugates, and so we end up with the square root of x squared plus x, the first term squared, minus the square root of x squared minus x, the second term squared, and the denominator is the square root of x squared plus x plus the square root of x squared minus x. This limit is now x squared plus x minus the parenthesis x squared minus x over the square root of x squared plus x plus the square root of x squared minus x. And we simplify the numerator. X squared minus x squared canceled out, so we end up with x plus x minus negative x is x. The square root of x squared plus x plus the square root of x squared minus x. And so this is the limit at x goes to infinity of 2x over the square root of x squared plus x plus the square root of x squared minus x. Once again, we will employ the trick to find the limit when we have the numerator and the denominator. We would divide by the highest power in the denominator. The highest power in the denominator is the square root of x squared. So we would multiply the numerator with 1 over the square root of x squared and the denominator with 1 over the square root of x squared. Keep in mind that the square root of x squared is just simply x. So we have the limit at x goes to infinity of 2x over x in the numerator, and in the denominator, the square root of x squared over x squared plus x over x squared plus the square root of x squared over x squared minus x over x squared. Again, we take every single term and multiplied it with 1 over the square root of x squared or divided by 1 over the square root of x squared. Notice that in this case, we use the fact that the square root of x squared times 1 over the square root of x squared is the square root of x squared over x squared. We then simplified each of these terms. The numerator is now 2 only. The denominator is the square root of 1 plus 1 over x plus the square root of 1 minus 1 over x. Now, at x go to infinity, 1 over x go to 0, 1 over x go to 0, and so we end up with 2 in the numerator. The square root of 1 plus 0 is 1, plus the square root of 1 minus 0 is 1. And so this is 2 over 2, so the answer is 1.